students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we'll be learning our very interesting topic, that is symmetry. Now in this chapter, we will learn about the reflection symmetry, line of symmetry and some examples of linear symmetry. Now let's start with the introduction. Symmetry means half of the object is same as the other half. So if you fold the object on half, one half completely covers the other half as shown in this figure. Now in the above circle, first half A is same as the other half B. So if the circle is folded on its half, then PEQ is same as PBQ. In the same way, these figures are also symmetrical. All the above three figures are symmetrical, so the line PQ, all are symmetrical, and PQ is what? The line of symmetry. Now reflection symmetry. Reflection symmetry is called the linear symmetry. Now in an equilateral triangle ABC, if ABC is folded on a dotted line PQ, then the designs on two sides of the dotted exactly coincide with or overlap with each other. So A is folded on A, D is half folded on D, B covers the point C where the triangle folded on the dotted line PQ. So we can say that a figure possesses linear symmetry or reflection symmetry. It means that two halves of the figure on both sides of the dotted line are mirror images of each other. Now look at the given figure. This is not symmetrical, this is also not, so none of them is symmetrical. Now let's look at the line of symmetry. Now a line that divides the figure into two parts that exactly overlap for coincidence when folded along that line is called a line of symmetry of the figure. Now in each of the following figure, the dotted line is what? The line of symmetry. Here the dotted line represents the line of symmetry. Some figures have more than one line of symmetry. For example, all these figures have more than one line of symmetry, and a circle has uncountable line of symmetry. Now examples of linear symmetry. A line segment is symmetrical about its perpendicular bisector. Let AB be a given line segment and POQ is a perpendicular bisector of AB. OE is equals to OB and this is our angle is 90 degree. So AB is symmetrical about its perpendicular bisector POQ. Now a given angle having equal arms is symmetrical about the bisector of angle. Let AOB is a given angle with arms OA and OB. OC is what? The bisector of angle AOB. So clearly both angles are identical and AOB is symmetrical about the bisector OC. Now an isosceles triangle is what? Symmetrical to the bisector of the angle included between equal sides. Now let a triangle be an isosceles triangle with AB is equals to AC, and let AD be with what? The bisector of angle BAC. Now if triangle ABC be folded along AD and then ADC coincide exactly with ADB, then ADC is what? Identical with another triangle. Now here AD is what? AD is the line of symmetry of triangle ABC. Now a kite also has one line of symmetry, namely the diagonal shown dotted is the adjoining figure. So ABCD is a kite, AB is equals to AD and BC is equals to DC. If we fold the kite along the line AC, then two parts coincide with each other. So ABCD is symmetrical about the diagonal AC. Now a semicircle ACB has one line of symmetry, namely the perpendicular bisector. So ACB is what? Our semicircle, and PQ is the perpendicular bisector of AB. So if we fold the semicircle along the line PQ, we find two parts coincide with each other. Hence the semicircle ACB, this part is symmetrical to the another part along the diameter AB. Now an isosceles trapezium has one line of symmetry, namely the line joining the midpoints of the pieces of trapezium. Let ABCD is what? Isosceles trapezium, in which AB is parallel to DC and AD is what? Is equals to BC. Now let E and F is what? Midpoints. So if we fold the trapezium along the line EF, then two parts coincide each other. So the trapezium is symmetrical about the line what? EF. Now a rectangle has two lines of symmetry, each of which the line joining the midpoint of opposite sides. Let ABCD is what? Rectangle, and P and Q are the midpoints of AB and DC respectively. Now similarly, if R and S are the midpoints of AD and BC, then rectangle ABCD is what? Symmetrical along the line RS. Now a square has four lines of symmetry, namely the diagonals and the lines joining the midpoint of opposite sides. So ABCD is what? Given square, and EFGH is the midpoints of AB, BC, CD and AD. So it is easy to say that it is symmetrical about the lines AB, BD, EF and GH. A rhombus is symmetrical about one of its diagonal. Let ABCD is what our rhombus, and we fold it along diagonal AC. Then two parts coincide with each other. So it is symmetrical about its diagonal AC and about its diagonal BD. Now an equilateral triangle is symmetrical about each one of its bisector of interior angles. Let ABC is what? This is our equilateral triangle, and AD, BE and CF are their bisectors of angle A, B and C. Now it is easy to say that ABC is what? Symmetrical with all its line AD, BE and CF. Now a circle is symmetrical about each of its diameter, and each diameter of circle is in what? Axis of symmetry. Now here a number of diameters of circles have been drawn. It is easy to see that a circle is symmetrical about each of the diameters drawn. Hence a circle has infinite line of symmetry. Now here it has infinite line of number of symmetry. Always remember, a scalene triangle has no line of symmetry, and a parallelogram also has no line of symmetry. Now each of the following capital letters of the English alphabet is symmetrical about the dotted line. All of these are symmetrical: A, B, C, D, E, H, I, M, O, T, U, V, W, X, Y. Now let's start with our exercise 14.1. In the first part, we have to do the line of symmetry and write the total number. So the line of symmetry that can be drawn here is 1 and another one is 2. So two line of symmetry can be drawn here. In this one we can draw 1 and another one is this. So two line of symmetry can also be drawn here. That's how you can complete the remaining ones. Now let's start with the multiple choice questions. We have to fill the correct option in the OMR sheet. Which of the following letters is symmetrical? Very good. A is our symmetrical. That's how you can complete the remaining ones. Here's our mental maths. Here we have to draw as many symmetries as you can. So in the first one, only one symmetry can be drawn. That's how you can complete the remaining ones. Now I hope you have understood the chapter pretty well. You just have to practice the exercise questions and don't forget to revise this topic again.